Hello everyone, and welcome back. So in this episode, we're focusing on character movement. This is crucial for our characters as they're all spawning in the same spot and we want to add some life and motion to the screen. So every character that we have that has a graphical asset or a root object, they're going to be able to move around on the screen. And let me go ahead and open up Stella here for a second. Okay, so we established when we were creating the characters that movement is going to be done based off of a vector2 value. We're doing this because we are operating in UI space. And for anyone who's done any kind of basic math, you're familiar with the graph, x and y coordinates. All right, so our scale that we're working with is normalized values on the x and the y. 0 on the x will represent left, the left corner of the screen, or the left side. And 1 will represent the right side, which means 0 for the vertical axis, y, will represent the bottom, and 1 will represent the top. So if we say 0, 1, then we want to go to the top corner, as high up to the top corner as we can go for the specific character we're using. If we say 0, 0, then as far to the bottom left corner as we can make this particular character go. So we only want to move as far to the left as we can go without taking our rect transform outside of the canvas, which means we need to subtract the width of this and find the appropriate position. Same thing for the right side and the vertical as well. We want to keep our rect transform inside of the canvas at all times, even when we're moving from the 0 to 1 values. Now, if we decide that we want to move past the canvas, all we have to do is just provide a number that's less than 0 to go outside the left of the screen, or greater than 1 to go outside the right, and same for the top. So you can move your characters anywhere, but on 0 to 1 normalized values, they will stay right within the canvas. Okay, so just like show and hide, this is going to be something that's accessible on all the character types. Only for text characters, they won't do anything with it. So let's go ahead and define a way for us to do it simple and just set the position, and then we'll focus on moving to a position later. But we're going to immediately set our position to a specific point on the canvas. We're going to make this virtual so that we can override it for the other classes. This is going to be a void return type, and we're just going to call it set position. And we'll take in that vector2 that we were talking about for the position we want to be at. And this is not going to operate off of the rect transform position. Instead, we're going to operate based off of the anchor positions that we have for our rect transform. Now, we can't simply apply 0 to the minimum x or whatever our position is. We can't just apply this directly to our minimum and maximum anchors because we want to get an offset. If we set our target position x-axis to 0.5, then we don't want the left of the character to be at 0.5. We want them to be positioned in the middle of the screen, which means we would have to divide that in half and find the center point of the character and position that at 0.5. So we're going to need to convert this vector2 position into some coordinates that we can use and apply relative to this character given their anchors. So let's make a dedicated function just for that. And this is going to need 2 vector2s to return, because if we look at our root, what we're going to be setting is anchor min. And anchor minimum is a vector2, which has a x and y axis. So this is the lowest x and the lowest y coordinates, the anchor positions for the character. And then we have anchor max, and that's the same thing. That's the highest x and the highest y. These 4 together define the total size of the rect transform that we're dealing with. So we need 2 vector2s to get from this return position. So let's get ourselves a function that we can access on all the character types. We'll do protected a vector2 tuple return, and we'll call this something very obvious. Convert UI target position to the relative character anchor targets. And we're just going to take in the vector2 position. So what are we doing in here? First thing is we need to find the padding. How thick and tall is this character? That'll give us whatever offset we need for our given target position. So vector2 padding, the size of this character is going to equal the root.anchorMax minus the root.anchorMin. And now with this padding, we need to define the maximum x and maximum y movement range that we have. The way we can get that is we'll start by defining max x. This is the total amount of space that we can move for this character. And so we're going to have to take into account the default maximum range. If we're operating at a normalized value, it's going to be 1. That's from left to right, unrestricted movement. But we're going to subtract that by our padding.x. And so we'll do the same for max y as well. Max y equals 1f minus padding.y. And now we need to get our return values and send those back. So we'll make a vector2 for the min anchor target. And this is going to equal a new vector2. And what we're going to take in is our max x, the maximum movement range that we can possibly move this character in a normalized value, and multiply that by our target position. So position.x. And we'll do the same thing for our max y. So max y times position.y. And that is the minimum anchor target for our character's root object. And to get the max anchor target, pretty easy. All we say is vector2 max anchor target, and this is going to equal our minimum anchor target plus the padding. So we just move it according to the size of the character. And now we can return both our min anchor target and our max anchor target. So we're going to go ahead and grab those two values in set position. So vector2 min anchor target and then vector2 max anchor target is going to equal convert our position. Convert our position to the targets. And from here, we'll just say root.anchorMin equals min anchor target, and root.anchorMax equals max anchor target. And this should set our position on screen. So in our testing script, before we show the characters, what I'm going to do is I'm going to set their positions. So guard1.setPosition, and I'm going to say vector2.0. I want them to be at the bottom left. Guard2.setPosition, I'm going to set him to the middle of the screen. Vector2, then 0.5f and 0.5f. And then guard3.setPosition, vector2.1, which means the top right of the screen. And if we run that in Unity, we indeed get them set apart just the way they should be. So let's take a look at that in the scene view. If we look at guard1, he is indeed set all the way to the left and to the corner according to the size of his rect transform. If we look at the character 2, yep, he's positioned right in the middle of the screen, so that's working. And guard 3, he is right at the very top right corner, so he is set in the exact position he should be. So as long as you're operating on 0 to 1 values, they will not leave the screen, and you will always be able to see the art that you have set, that you have desired to see based on the size of your root. Now what I could do is, to show the different sizes of these characters in action, I could say Raylene, and then create Stella, and then maybe we'll do guard 4 and just make this female student 2, and then I'll do set guard 4 position equals new vector 2, and set this to 2 on the x-axis and 1 on the y-axis. Okay, and if we run that, we get these 3 characters visible here in the screen. Let's go into scene, and where did my female student 2 go? She went way out here. So we had, she should be visible, there we go. So yeah, by setting her outside of 1, she's able to leave the screen. And let's take a look at their rect transforms. So the guard at 0, 0, he's in the right spot. Raylene, she is centered in the screen, and Stella, she's also placed exactly where she should be given her rect transform. So no matter what the size of your character, they're going to be moving to the right position. But speaking of moving, let's go ahead and start the coroutine that will let us smoothly move from one spot to another. Just in case we are trying to run this on a text character, let's go ahead and take set position and say that if root is not equal to null, then just return. And now public virtual void move to position. We'll again take a vector2 for the position, and we'll specify a speed, which I'm going to default to 2. And then we'll also specify another boolean for whether we want this to be smooth and lerping or not. And by default, I'll set that to false. Alright, so if we're going to operate on another coroutine, just like our show and hide, we should make a reference up above. So we have our coroutine for CO revealing, CO hiding, and I'm going to make another one for our protected coroutine CO moving. And then let's make another public boolean for is moving and set that equal to CO moving is not equal to null. Alright, so we know if we're moving or not, and let's try to make our IEnumerator. So we'll do a private IEnumerator, moving to position, vector2 position for our target. We're basically going to take the same parameters up above, so a float for our speed and a bool for our smooth. Now when we call for this character to move to the position, let's check if we are moving or not. If is moving, then we need to stop it. And remembering that all of our coroutines are running off of the character manager, let's reference our manager.stop coroutine and reference CO moving. Now that we know we're not moving, we can say CO moving equals manager.start coroutine, and we are going to run the moving to position, passing in our position for the target and the speed that we want to move at, and whether we want to use it smoothly or not. And let's make this, instead of a void, return a coroutine. That way we can yield for it and return CO moving. So this comes our logic inside of the loop. We need to get our minimum target just like we did before. So let's go ahead and grab this little boy here. Pop that in there. But first of all, if root is not equal to null, then I'm going to return in move position. So return null. Okay, so if we're running this, we need our UI target, and we get that for the minimum and maximum anchors. And we're also going to want to get the padding for the character. So let's get ourselves a vector2 for the padding of the character and set that to equal our root.anchor max minus our root.anchor min. Okay, and now let's loop for as long as it takes us to reach that position. And we can evaluate that through our anchor points. So while root.anchor min is not equal to min anchor target, and, or actually not and, or we want to run these two no matter what, then root.anchor max is not equal to max anchor target. As long as any of those conditions are true, then we are going to try to move. So we need to figure out what our minimum anchor position is now. Let's go ahead and say root.anchor min equals, and evaluate if we're smoothing or not. If we are not smoothing, we're just going to move. If we are, then we're going to lerp, of course. So let's check smooth. And then this is going to be a long line if I try to keep it on one. So I'm just going to separate this into different lines here. So if we are smoothing, then we're going to use vector2.lerp. And what we're going to move from is our root.anchor min, where we currently are, to our anchor min, or our min anchor target. And we're going to move by the speed times time. Good lord, time dot delta time. Okay, now, if that is not it, and we are not going smooth, then we're going to do vector2 dot move towards, again from the root dot anchor min to the min anchor target, and then to the speed times time dot delta time. But if you're working with lerping and moving towards, then you know that lerp takes a lot longer to reach its target than move towards will, because it has that fall off range. And if you were to look at the two side by side, it would look like move towards gets there a lot faster than lerp does, even without the fall off point. And that's because the calculations are different. So we need to just slow down our move towards, so that way if we're lerping or if we're not, they're both kind of moving at the same speed. And I'm going to slow this down by, say, we'll slow it down to 35%, and that should be good enough. So after we figure out what our minimum anchor is, we can now set our max anchor. So root.anchor max equals our root.anchor min plus our padding. And on that same note about lerp taking a long time to reach its target, it could take a very long time to reach its target, even when it looks like it's finished, because it's moving in micro increments. And so that could take a very long time for our coroutine to finish, and if we're waiting for it to finish, we're going to be waiting for a long time. So let's set ourselves a threshold, and then just go ahead and force it to complete if it's within that threshold. So if smooth, first of all, if we're using lerping, and let's evaluate how close we are to the target. Vector2.distance can show us that, because we'll be evaluating the root.anchor min to our min anchor target. And we're going to check if that is less than or equal to a very small amount, 0.001f. Very small amount. But if we are less than or equal to that value, we know we are close enough to go ahead and finish it. And we'll go ahead and say that root.anchor min equals min anchor target, and root.anchor max equals max anchor target. And then we're going to break out of our loop. But while we're running this loop, let's not forget to yield return null. Otherwise, we will be caught in the crash that ensues if you do not yield in your coroutine. And then once we're done, let's go ahead and just log ourselves a debug message. Let us know we're finished. Debug.log, done moving. And we can say that co moving equals null. Okay, in test characters, now let's see what we can do here. I'm going to say yield return guard.move to position vector2.1. After he's moved to that position, then I'm going to move back to vector2.0. And it looks like I did something wrong because all my characters are in one spot. Yeah, they didn't even set their position. And sure enough, that would do it. I need to check if the root is null and then return. So now let's try this in Unity and see what happens. Let me go ahead and make sure I am showing them before I try to yield for the movement. That way I can see it happening. And I'm just going to also yield return for how long it takes the guard to show up. And once he shows up, then I'm going to start moving. There we go. So he's moving, and he's able to move to different parts of the screen. Little jerky, because it's just linear movement. So let's go ahead and see how lerp looks. For that, I just need to change our smooth to be true on both of these. Okay, let's try this again. And he's moving, he's lerping, and there he goes. He finished, and there. So if we didn't do that force complete there, we would basically be sitting with him in the corner of the screen just waiting for the longest time, because that's how lerp works. But there we go. That is movement. That is setting position and moving them on the UI. So we can move them all across the screen, move them out, bring them in, have them enter that way, use a combination of fading in as well as moving in on screen. And all of these things will tie together, especially once we start working in dialog files. Again, if we look at the code, this is a whole lot of commands and referencing the character classes. So we know that we're going to be taking these in a later video, and we're going to be converting all of these into commands for the dialog system. And set position will be actually converted into the casting data for the character casting. When we do a character at certain position, that would be calling character.setPosition here, just as an example. And then we'd have another function like character.moveTo, and that would call the character.moveToPosition, followed by whatever parameters we throw in. So this is laying the groundwork for us. We're getting all these functions in, and the next thing that we're going to focus on is actually a small step of making sure our characters are named correctly when we spawn their prefabs in the scene. So that's going to be a simple video, and that's the one coming up right after this. I'll see you there.